Dear participants, on behalf of Department of Geography and Internal Quality Assurance Cell, ASP College Devruk, and all the collaborating institutions, I welcome today's resource person, Dr. Deepali Gadkari ma'am. As I already told before she joins the session, she is a geomorphologist and moreover she is one of the leading faculties who are working in the area of geospatial technology. We are very eager to listen Dr. Deepali Gadkari ma'am. Before proceeding ahead, I would like to invite my colleague Lalita Tambe ma'am to introduce today's speaker. Tambe ma'am, please proceed ahead.
Yes, sir. Yes, sir. Thank you, sir. Respected Vice Principal and Head of the Department of Geography, Dr. Sardar Patil, sir. Respected Resource Person, Dr. Deepali Gadkari, ma'am. All the researcher and academicians, good evening. Good evening to all. We are on the 13th session of the 16th day training program on digital image processing. I have been given this opportunity to introducing Dr. Deepali Gadkari ma'am. Before starting the session, I would like to give ma'am's introductions. If we are talking about academics, her basic discipline in geography, her master in geography, specialization in geomorphology, and MPhil in application of remote sensing for estimation of suspended sediments. And ma'am done her PhD in application of remote sensing for earthquake studies from University of Pune and diploma in geoinformatics CDAC Pune, certificate course in aerial photogrammetry and remote sensing IIRS Dehradun, and online courses in disaster preparedness in Petersburg University, USA. And Madam is currently working as a assistant professor in geography, Department of Geography, University of Mumbai. She is a PhD guide since 2016. Current three students are pursuing PhD under ma'am guidance. Total experience around more than 18 years of a teaching experience. Additional responsibilities handled by ma'am, that is, she is a PhD course coordinator, Research Center, Department of Geography, University of Mumbai. Total research experience around more than 5 years, more than 5 years. And research projects are ISRO sponsored project, University of Pune as a JRF and SRF. So 4 years. Institute of Seismological Research, Gandhinagar, Gujarat as a visiting scientist of 4 months. SECOA International Project on Coastal Studies, Science and Technology Park, Pune as a research associates for 9 months. 11 total research paper published by ma'am, that's 11 total research papers published. And interest areas are like geoinformatics, coastal geomorphology, seismotectonic studies, fluvial geomorphology, disaster management, and one research project completed by ma'am, that is analysis of spatio-temporal changes in mangroves from the Vasai Creek to the Thane Creek, Maharashtra. And some national level training programs are done by ma'am, that is Python and GIS, surveying the total stations, research and publication ethics, spatial database generation and utilization using GIS technique for Swasti Agro and Bioproducts Private Limited, Pune. Geoinformatics for earth science and management of natural resource, collaborating with ISRI. And another international level training program also is done by ma'am, that is special training course on application of GIS at Faculty of Geomatic, Computer Science and Mathematics at Stuttgart University, Germany. and another is training program of faculty member of Kelania University, Colombo, Sri Lanka. Oh. So today we have a very dynamic personality among us. There is no doubt that ma'am's lecture will also be in the same manner as madam's introduction was. So ma'am, I also as well as all the participants are eagerly waiting to hear you. So I am welcoming you behalf of Devruk Shikshan Prasarak Mandal, ASP College, Devruk, and all the collaborating institutes. So you can proceed ahead, ma'am. Thank you. Thank you so much.
Thank you, Patil sir, and thank you, Tambe madam, for nice words and nice introduction. Uh, I'm just trying to pursue the things which I like so for all these years, and um, I'm very much thankful to Atle Sapre and Pitre College principal, managing and body of the college, vice principal, um, Dr. Sardar Patil sir. We often have a chance to interact in various capacities. Basically, as a coordinator, I interact with all the guides who are affiliated to Department of Geography, University of Mumbai, and I always get a very good response, very good support from all of them. Parmar sir is also there. I think Narkhede sir is also there. I could see their names in the, and I'm equally thankful to the all the collaborating institutions which are there to organize this nice workshop. Basically, I would like to just reflect upon this digital image processing workshop. uh, we started this paper uh, at master's level, I think in 2018, 17, 18. And since then, I was waiting to get a good response for this paper. So for some years, there were some good students. Some years there were not that many students for this paper. It is such a useful paper, and I had worked on some projects, ISRO sponsored projects as a JRF, SRF, and I found that yes, these image processing techniques are very, very important, and as geographers of this century, all should know, I mean, all the geographers should be able to utilize this satellite information for various purposes. Some may be working in the field of geomorphology, maybe urban studies, maybe disaster management, whatnot, any field. But there are so many things which we can explore. Uh, I started working with remote sensing way back in 1996 when I took admission for MPhil. My guide at that time, I mean, I was at least not competent to choose my own topic and say, "Ki sir, mujhe is pe kaam karna hai." So whatever guide suggested, we took it up, and it was estimation of suspended sediment using remote sensing data. So at that time, we were not having these software, sophisticated software like IRDAS or say ArcGIS, or even QGIS was not there. Our guide, Professor Job, he had developed a small software on which our work was being done. I mean, he developed this software with help of his nephew, who was a computer engineer, and with his who was a programmer, and with his help, he developed this technique. At that time, we were getting floppy products. I mean, now we will be surprised. You will be surprised to know that at that time, CD products were not there, and NRSC used to supply floppy products, and that software was designed to process those floppy products. Floppy पे data आता था NRSC से. So my MPhil work has been done on one of such indigenously developed, now we call it software, by my own guide. I'm very proud to say that. And in that we had used individual bands. Now by this time, you must have learned many things in remote sensing, I'm sure. So we used blue, green, red, and near infrared bands and tried to correlate it with ground uh, what ground readings. What we were doing is we were trying to correlate the percentage of suspended sediment in near coastal zone with the sediment, with the remote sensing data. So we had taken a boat, we had gone to the near shore area. We had placed three theodolites with two persons on each theodolite on the coast, and which were trying to locate the boat का location mark करना was equally important at that time. Please remember that we were not having mobiles, we were not having GPS. Huh? So the only source of locating the points in the sea was to keep the theodolites on the coast and take the locations, I mean the angular distances from the theodolites. It was a very innovative exercise that my guide had planned. And this is how we tried to we collected the water samples. We came back to the lab and filtered those samples to calculate some per liter suspended sediment, and then this per liter suspended sediment also we had depth values, and we tried to correlate remote sensing data with this ground values, and we could get very good combinations. At that time, indices factor, this concept of indices was not very popular. We were just starting with something, and we had taken additions of bands, subtractions of bands, and divisions of bands. Multiplication was not done because it is just the inverse of it. So blue band, that is band 1, band 2 is green band. We were let me tell that also. We were using list 2 data. List 2 data. So list 2 data mein uh, list one data mein blue band was there, and then it was removed. So we were trying to take the various combinations of bands and trying to correlate the ground measurements, like ground not ground but water samples से जो निकला था, suspended sediment, amounts of suspended sediment, how do they vary with each band, or do the reflectances vary with the percentages of suspended sediment? That was the exercise, and we could get some very good correlation with green and red bands. As far as I remember, yes, green and red band का addition के साथ बहुत अच्छा correlation मिला. So indirectly or directly we were using various indices. So that was the beginning of using indices for me, and later on remote sensing since then uh, developed in India also and world over also, and there was prolific development of all the techniques, and people started using various sophisticated tools and techniques of remote sensing. So now let me start with today's topic, enhancements and transformations, part 4, image indices. So I'm sharing my presentation. Mm, just a minute. Can you see my presentation? Is it visible? So with that background, I would like to start with why image indices. Today's topic is image indices. Uh, so image indices, and they are useful in escalating the differences between band values. See, the band values could be very close to each other. What is the basic purpose of remote sensing images? Identification of features, right? Delineation of features, identification of features. So when the identification of two features is better, when the reflectances or the reflectance values between these various land uses or land covers are better, more the differences, much easier is the identification. So sometimes it happens that the differences between the band values, they are very low, they are very less, and that is why we need to escalate the differences between band values, and indices help us escalate this band value, that these differences in band values. So that is the first reason. Um, so that we can identify the spectral patterns of LULCs. Popularly, land use land cover is referred to as LULC in remote sensing in geography. Uh, so more effectively, the spectral patterns can be used to identify the features. Then when we say that it is a index, it gives us value within some range. So similar indices can be comparable. So, the values of indices become unitless and they become comparable also. So most of the indices vary between -1 to +1. So what is -1 and what is +1? The lowest and the highest limits. We'll see now. So this is why the image indices are basically used for. And then this you must have done, but still to start with, actually what is a digital image? It is a matrix of some digital values. So reflectances are converted into radiances, are converted into reflectances, reflectance into DN values, and these are the DN values. So in 8-bit images, they are scaled between 0 to 255. So uh, all the values are scaled on one scale, whatever the scale is, radiometric scale is. If it is 8-bit, then the values will range between 0 to 255. So these values, they represent some reflectance, and the values will vary as per the reflectances. Here you can see one for lighter shade, and as we go towards the darker shade, the value has increased. So maybe this is one band, whatever it is not specified. This is just schematic diagram. So for each band we get band wise values like this, and then we use some of the bands. There are many more. There is NIR band also, SWIR band also, and so on. But usually these 4-5 bands, these 3 and plus NIR plus SWIR bands are used for remote sensing purpose. Now we should remember that before using any index, uh, there are some pre-processing steps which should not be missed. What are those pre-processing steps? So all the band values should be in the same scale. Here by scale I mean radiometric resolution. They all of them should be on same radiometric resolution. I mean, if all are on 8-bit, they will be scaled between 0 to 255. All are 7-bit, all are 9-bit, 10-bit. Mostly the images are, but either 8-bit, mostly 8-bit or 10-bit. Uh, then while calculating any spectral index, atmospherically corrected reflectance value should be used. Now, why this is very important? You must have learned. There was one topic, ना पाटिल sir, atmospheric corrections का एक topic था आपके इसमें. Yeah. So they know what atmospheric corrections are. Now, can anybody tell me why atmospheric corrections are necessary while before applying any image processing tool for that matter? I mean, even if it is supervised, unsupervised classification, or whether you are applying any index, why atmospherically corrected reflectance values should be used? Can somebody tell me? Just try.
It is to remove the external errors from the satellite image.
Yes, and especially when we are going for change detection, it is extremely important because two images may look different. Even if there is no change, they may look different only because of the atmospheric influences. The suspended matter in the atmosphere may vary, illuminance conditions may vary,
And
water
I
vapor
think
content may vary, and so on. So the reflectances are influenced by all such matters, and that is why atmospherically corrected images are necessary.
yes, ma'am. And I think if we use the two tiles that is covering the any study area or area of interest, then maybe there is different of sun angle, elevation, different things. So we need to
Yeah, that is,
reduce
yeah.
this error and bring them in one dimension scale 0 to 1 like this.
Right, right, very right. Who was that? May I know?
Yes, ma'am. It is myself, David Durjoylal Sore.
Okay, thank you so much. Uh, uh, so, these are some of the necessary conditions, and before applying image indices, we should always remember this. Now, though NDVI is not there, I have added because mostly the things started. इसके पहले भी कुछ indices design हुए, लेकिन mostly NDVI could be taken as pioneering index, image processing index, and why? And many vegetation indices were developed first. Why this must be so? Any guesses? Why vegetation indices first?
To identify the
Hmm?
vegetation.
Yes.
To identify the vegetation.
Yes, most of the Earth's surface, the most widely spread land cover is vegetation, and vegetation studies were always important for human life, and that is why mm, people first developed vegetation indices, and this is one of the most commonly widely used index. So I thought I should start with this. Um, Most of you must be knowing what this index is. Here we will see. So it uses NIR band and rate band. NIR minus R divided by NIR plus R. In a very simple formula. Then let us see what happens actually over here. When there is healthy vegetation, near infrared, which is incident upon uh, vegetation canopy, 50% of it gets reflected back. While visible, that is red band here visible means red band, it is also incident upon from the same spectra, and only 8% of it gets reflected when the vegetation is healthy. The chlorophyll content is more. If chlorophyll content is more, then most of the red is absorbed and near infrared is reflected. Now here you can see, now this vegetation is not having much of the uh, chlorophyll content, and what is the condition? This reflectance is less. This was 50%, this is 40%. And here reflectance of red has increased drastically from 8% to 30%. And now here you can see the effect of it. This has not much varied, but there is drastic change in the reflectance of visible band here, red band. And so in the first case, the NDVI value was 0.72, whereas here it has gone down to 0.14. In this way, it served as a very good tool to know firstly the vegetated areas, secondly to assess the health of vegetation, and thirdly to assess the health of crops. So healthy crops कहाँ हैं and unhealthy crops कहाँ हैं, इसका mapping करने के लिए it served as a very good tool. So as you must be knowing that it varies between -1 to +1. Uh, but there is not a distinct boundary for each of land cover. Hmm. I mean, if it is a say deciduous forest, if it is a grassland, if it is a bare land, uh, bare land hai to of course there will be some decisive value, but otherwise there is no such distinct boundary for each type of land cover. When you have negative values, it is highly likely that it's water. Negative values जहाँ जहाँ होते हैं वहाँ वहाँ mostly water water body है तो because what happens this NIR का reflectance in water is theoretical zero. There will be some reflectance of NIR from water bodies only if there is some if there are some impurities like say some sediment is there or some vegetation is there, aquatic vegetation is there, then only there will be some reflectance in NIR. So on the other hand, if you have an NDVI value close to 1, there is high possibility that there is it's dense green leaves and the vegetation is very healthy. Close to zero, there are likely no green leaves and it could even be urbanized areas. So if you try to separate out built up area in a city from vegetation of any type, then you can apply NDVI and low NDVI values or near zero, sorry, not low, but near zero NDVI values give you a very good separation between urbanized areas and say vegetated areas. So I had applied this NDVI to demarcate urbanized areas and you could get a very good separation out of it. So at this point we have already discussed. So if you want to compare images of 2 times, that is change detection, you have to go for atmospheric correction. Now I could find a very good paper and I thought I should share this with you. This is not just application of NDVI but using NDVI values for further modeling. और अब ऐसा नहीं होता कि बस एक इंडेक्स यूज किया और हो गया रिसर्च. It has proceed further to use these indices in combination in modeling and so on. So I could find this example very useful. Uh, so here you can see that NDVI values are given. So and then these are the vegetation densities found. And mm, here areas of rice plants. So this paper applied NDVI to know the how the rice crop is distributed over a region and what is the productivity estimation. So they have used NDVI values for productivity estimation. It's a very good example how NDVI values can be used for modeling. So they have tried to correlate NDVI values with rice productivity. See, this is the spatial variation, and here you can see the legend. It is not readable, I know. That is why I have put a reference over here. You can download this paper and you can read it. It is a very good article. Here you can see, please see this table. Now they have also done the validation. We should always remember that whenever we are using an index, we are applying any model, uh, validation with ground data is very, very important. And here Here they have done the same. See, this is their estimated productivity. So looking at the NDVI values, they had estimated this yield ton per hectare, and from the same patch, it is the actual product. It is the actual produced. So here it is 6.256 tons per hectare, and here actual is 6.07. You can just have a look at this table. These are the sample points, sample patches, you can say. And then you can see that there is a very good correlation between estimated and actual. So in this way, in many ways, people have used NDVI values. So this is one of the examples which I could uh, see, and I thought I should present it before you. It is some study done in Indonesia. Uh, then people were constantly working on this index, and in 1988, Ute, he found that NDVI, yes, it is giving good picture of vegetation health, but still there is some reflectance from the soil also. So soil also is playing very important role, soil and surrounding things. Now here we should just visualize a landscape, a farm maybe, or whatever, a forest, where there could be some patches, some areas which are not vegetated, which are bare soil areas, and they will give some different type of reflectance. And uh, these reflectances should also be taken into account while interpreting the images. So he added one factor, and then the index was slightly modified, and then it was called soil adjusted vegetation index, because it is now taking care of soil factor also. And the reasoning is what? The iso vegetation lines are not parallel. They do not all cover at single point, converge at single point. It, basically, the vegetation varies from place to place. Even if it is a single plot, vegetation densities will vary, vegetation type will vary, the health of vegetation will vary, and so on. So these uh, lines are not parallel to each other, iso vegetation lines, and they do not converge at single point. So SAVI, it is popularly known as SAVI, SAVI, Soil Adjusted Vegetation Index. It introduced this L factor. Otherwise the formula is the same as NDVI. You can see NIR minus R and NIR plus R, unka ratio. The L factor ranges actually from 0 for very high vegetation cover to 1 for very low vegetation cover. 0, if this is 0, then this factor is almost removed, and then it will be just NIR minus R, NIR plus R wala formula, that is NDVI formula. But if low vegetation cover is there, then what will happen? Then the influence of soil will increase, and that is why the value of L should be increased. There are some techniques to calculate this, compute this L factor, and this L factor computation uh, is a bit difficult. I couldn't get a clear, I mean, a formula for it or something, some indicative material like that. So I'm uh, here I could get only one thing, that 0.5 is typically used. So 0.5 indicates intermediate vegetation cover. So it is safe to use this 0.5. If you are very sure that the vegetation is very low, then you can use 0.7, 0.8, 0.9 maybe. If you are very sure that vegetation is very, very dense, then you can use L factor as 0. But otherwise, it is taken as 0.5. So again, in IRN, red band should be in same scheme. So NDVI needs only what is different between these? What is the difference between these two indices? NDVI, as we have already seen, needs only spectral measurements, whereas SAVI needs L factor, L parameter also, and it is not that easy to estimate it accurately. This is because all soils are not equal. They are not alike. They have different properties. They will have different moisture contents. Even if two regions are having the same type of soil, the moisture content may be different. The treatment given to the soil may be different, and that is why computing this L factor becomes a challenge. So soils have different reflectance spectra due to many factors such as soil moisture, organic matter in soil, then mechanical composition, and many other things. So safely you can take it as 0.5. Uh, Again, here are the formulae for NDVI and SAVI. You can see it here. Uh, so it considers the effect of soil background also, SAVI. We had used, when I was teaching in Pune University, me and my student had done one study in Kara River Basin. There was a small dissertation. Nazire Dam along there is one dam called Nazire Dam, and uh, a canal system is there from this dam, and how this canal system has affected the uh, or influenced the cropping pattern over there, and how far it is helpful to, and how far it has done some damage to it. So we had collected some samples, soil samples from these areas. If you can see, these are the sample points. These are the sample points. So this is for NDVI 1976 का इमेज भी लिया, और उसके ऊपर दोनों indices अप्लाई किए, and we could see these values, and I mean 0.1 to 0.2, these purple these patches, greenish patches, if you can see these patches. So the NDVI values varied between 0.1 to 0.4, whereas SAVI values varied between 0.2 to 0.7. Now you'll see why these values, two indices are used, and these are the salinity affected areas. So these areas we were interested in knowing कि यहाँ क्या हो रहा है. And then also we applied these to 2010 images. So these areas had changed a bit. Here also you can see we compared these areas, and then uh, we could find that these areas, SAVI images, are more useful than the NDVI images, because we could differentiate between so many land uses and land covers. We could correlate these SAVI values with, say, settlement, or fallow land or sand dunes, then waterlogged areas or canal. Crop affected by salinity could be differentiated. Normal crop could be differentiated with these values. So we found that SAVI index is more effective than NDVI. So again we come to the theoretical part of SAVI. all the vegetation indices assume that there is a soil line. Now, what is soil line? It is a a plot of soil in two band remotely sensed data. So, soil reflectance in say NIR band and soil reflectance in red band. When they are plotted against each other, it gives you one line, one soil graph, and that is in it represents red and NIR space. So it is in single slope. So that slope of that soil line clearly shows where you can use this band or this band. Both the bands are necessary, but if you use L factor with these bands, then your calculations become more effective. So let me just show you the scatter plot. What is done over here? You can see this is not soil graph. This is the correlation graph between SAVI and NDVI. You can see SAVI values are plotted on the x-axis and NDVI values are plotted on the y-axis. Now, after certain point, what is happening? What is happening is NDVI values which are lower than zero point 0.2 up to this point indicate no vegetation, just soil. And negative values are either water or urban areas. So 0.2 के नीचे, यहाँ से नीचे NDVI values, what do they indicate? They indicate no vegetation, just soil. And negative values start from here, minus 0.1 and so on. So these values for NDVI, they indicate water or urban areas. The higher in NDVI values, yes, dense vegetation, more healthy vegetation, same stands true for SAVI also. But NDVI starts saturating after the value of zero point 0.7. After the value of 0.7, these values start saturating. They cannot differentiate between healthy, very healthy vegetation. Well, SAVI at this point is only 3. You can see that when this is 0.7, SAVI is not much. SAVI is ज़्यादातर 0.3 का ज़्यादा यहाँ है. These values come in this region. So SAVI has still more space to go beyond 0.3 and say that 0.4 is more healthy, 0.5 is even better, and so on. So saturation of NDVI takes place at early stages, while SAVI can give you more, you can say, slabs of say dense vegetation, and it saturates less fast. Saturation here means that after attaining a certain value, उसके उसके बाद कितने भी हो, मतलब more than 75% marks is distinction. फिर 80% भी उसी में, 85% भी उसी में. If there is no O grade, that is outstanding, all are freezed at distinction, isn't it? When that O grade is added, then what happens? You get still more distinction between 75 and above, maybe more than 80, more than 85, more than 90. If you go on adding such slabs, then yes, the separation is much more. Likewise, in SAVI, there is a lot of scope to differentiate between healthy and healthiest vegetation, dense and more dense vegetation. Okay, so here we should again remember that L parameter needs to be adjusted when having more dense vegetation cover. If the vegetation cover is more and more dense, then L factor has to be properly adjusted. So this was about ACVI. Any additions, any suggestions from you? You are always welcome to stop me and ask the questions also. I will try my best to answer your questions. Otherwise, we will go to the next one. Shall we go to the next index? So, yeah. Okay, fine. So, this is normalized difference, snow index. Uh, in your program, it is NDSII. So that one more I is added for ice. There is some difference between snow and ice, physically speaking. One is more compact, the other one is more compact, so more dense, and the other one is less compact. So, but both are to be mapped, and both are very important components, especially in the glaciated areas, especially in the high latitude areas and so on. Now, why they are so important? Let us have a look at these points and then we will proceed. So, snow, it is climatological, global climatological phenomena. It is a very important, serious constituent of hydrological series, hydrological cycle, and ecological hazards also. Uh, in some parts of the world, like in tropical countries where the snow is found, ice is found, snow is found only in the high rise areas like Himalayas or other such lofty mountains. But in higher latitudes like Scandinavian countries, northern Europe, northern America, and so on, snow is found at sea level also, even at sea level. And their snow mapping is very, very important because it becomes one of the hazards. In our case, like we know our big rivers like Ganga, Yamuna, Brahmaputra, they have their origins in the glaciers. So, how much ice gets accumulated in winter will definitely, or it definitely affects the flow of water in these rivers which are having origins in glaciers. So from viewpoint of availability of water, from viewpoint of agriculture, industry, and the whole life, uh, this is very important to know how much ice or snow is accumulated there, how much of it is going to enter into the hydrological cycle, then which areas are occupied often by covered by snow, and they are like disasters in those areas, in high latitude areas. You must be knowing that in America recently there was a snowfall, and लोगों का बहुत बुरा हाल हुआ है वहाँ. Russia also faces. I mean, all these northern countries and extremely southern countries in southern hemisphere, they always experience these phenomena. And so snow mapping is very important. Um, So snow cover, knowing snow cover or identification of snow cover is important from viewpoint of hazard mitigation as well as catchment management. And see, again, there is a series of indices developed in this contest. Firstly, it was NDSI, that is normalized difference snow index, which was later slightly modified into normalized difference snow or ice index. There is one more index. It is forest snow index. I am not going into this. Basically, हम ये देखेंगे उसके बाद ये देखेंगे. So you will always find that this development goes on and on. NDVI करके लोग चुप नहीं बैठे, उसमें भी बहुत सारे variations आते गए. SAVI is one of them. So here also we should remember that there is a series of indices. Uh, so today we will discuss NDSI and then NDSII. The only difference here is they have added eyes ka I also, NDSII. So here NDSI threshold of more than or approximately equal to zero point 0.4 to highlight the presence of ice. If the areas are having more than 0.4 NDSI value, then yes, there is presence of ice. Now, which bands are used to calculate this NDSII? Uh, Basically, zero point 0.6 to 1.6 and 1.6 micrometer. So this is which band? Green band, and this is SWIR, that is shortwave infrared. Now, of course, there are some reasons, just like we saw it in the case of NDVI. Here, there is one reason, there are three reasons basically why these two bands are used. Basically, there should be transparency in the atmosphere. That means we should get an atmospheric window over there. The atmosphere should be transmissive for these wavelengths, and yes, here it is. The second reason is snow needs to be differentiated from clouds, because on image clouds also give very bright tone, bright reflectance, and it becomes sometimes very difficult to differentiate between clouds and snow. But at this 1.6 micrometer wavelength, snow cover absorbs sunlight. Snow cover will absorb sunlight and appears darker than clouds. Clouds will reflect these wavelengths, or around 1.6 wavelengths, but snow cover will absorb it. So it will look darker than clouds. So the darker in this band will be taken as snow. So this enables an effective distinction between clouds and snow cover. Uh, then it should also be noted that snow is not very reflective in visible part of it. So cloud cover reflectance remains to be high in the same part of the spectrum. यहाँ भी क्या होता है? यहाँ भी here also clouds are more reflective and snow is less reflective. So the differentiation becomes possible. This allows very good separation of clouds and snow. Now let us see this formula. TM, TM is thematic mapper of Landsat satellites. Thematic mapper is a sensor. See what happens with each sensor, the bandwidths slightly differ. And that is why you need to specify the bandwidths which you are using over here, because iska band 2 maybe band 3 of say apna Landsat 8, that is OLI sensor ka. So to avoid this confusion, it is a very good what can you say, good habit to specify the bandwidth over here. Band कौन सा आप स्पेक्ट्रम का कौन सा हिस्से की बात कर रहे हो, just specify it. So green में भी थोड़ा सा overlap. If you compare list 2 का green and TM का green and say OLI का green band, there will be, these limits will be slightly different, not much but slightly different. So it is better to specify these ranges. And then so green is band 2 and band 5 is SWIR. It is beyond NIR, beyond NIR. हाँ, रेड के बाद NIR आता है, NIR के बाद SWIR आता है. I'm sure that you have done the spectrum also. It ranges between 1.5 to 1.75 micrometer. So it is the ratio of NDSI is the ratio of band 2 का difference and band 2 and band 5 difference divided by band 2 plus band 5 का addition. So green and SWIR difference, green and SWIR plus and दोनों का ratio. Now here in NDSII, that is normalized difference, snow and ice index, this band is changed. You must have noticed in the previous case, NDSI, it was green band, and in NDSII, it was um, green was replaced by red band. Both range between -1 to +1 there also, and ad suffix threshold is that is point 0.4, similar to NDSI. So it was this is a very good research paper. You can just search for Zio et al 2001 uh, and NDSII. You'll get that paper. It's a very good paper. You will, if you read it in detail, you will know many more things. There are many more indices in this sequence also, but we should restrict somewhere. Uh, so this is a S3 index, and that is SWI index. I'm not going into the details of this, but another paper, this is Dixit et al. 2019 का paper है. It is another very good paper, research paper. You should go through it. It is a very good example of writing a paper on indices. They have compared indices also, uh, and sensors also, and methods of accuracy measurement also. So there are I think at least 3-4 types of comparisons they have done, and that gives you a very good and clear picture. So please read this paper. This is very good. If you search like this, it will be there. Dixit et al. 2019. Now I have tried to include some of the things from this paper itself. There are very few papers on NDSII from Indian scenarios, Indian writers, Indian authors. I could find this very useful also, and very well compiled paper. So this is their study area, Himachal Pradesh. This is particular later study area, and here see what they have done is they have tried to find out the subclasses of the study area. Clean snow, snow mixed with soil, and snow with some impurities, then vegetation, shrub type, and then vegetation, maybe trees, and then water. So what is the reflectance in green, red, NIR bands and SWIR bands? See, pure reflectances or mean reflectances of these bands as they are. Then as we know, these are the ratios, various indices, NDSI, NDSII, S3 is one more and SWI is one more. I have not talked about these two. Let us for the time being stick to these NDSII and NDSI. So you can see what are the mean values of these indices for clean snow, then snow mixed with soil, the values have slightly come down. The vegetation, if it is shrub, the values have gone to negative. Hmm. And then again, vegetation of a tree type of vegetation, that is again the values have gone down. And for water, the values are there. Hmm. And the values are much higher. So there could be some overlap or some confusion between water and ice. But here if you can see, here there are more differences between these values, S3 में or SWI में. There are the differences are more. SW values are much more than water values. Snow values are much more than water values. Snow with soil values are also much more than this water values. And the authors have in their conclusions said that more than NDSII, this SW and S3, these indices are more effective in differentiating between water and snow areas. Water and snow areas. So now let us see these images. So as you can see, this is Landsat 8 image. This is accumulation ka image and this is ablation. Accumulation uh, in winter and ablation in summers. So the areas which are showing snow cover, they are now uh, seen covered with vegetation. So ablation jab hota hai, that is snow gets melted up and then vegetation again grows. So at that time you can see these areas which are the red areas are vegetation, and this is snow, white is snow. Snow is remaining somewhere here and there. Here also you can see, and scientists go on comparing the images of from year to year. So year 2017 accumulation, 2017 ablation, 2019 accumulation, 2019 ablation. So these images, they have many more they have used, but I have cut some part of their images and I am showing you. So this is how they have compared. They have calculated the indices for the study area. This is the study area for the entire study area. They have done this, and then again, whatever theoretically we have seen over here, these values. See how the images look like. This is our simple multispectral image. Which sensor? Um, Basically, they have used Landsat 8, मतलब OLI sensor use किया होगा. They have given here name of not the sensor but the satellite. Then this is multispectral image. This is NDSI image. This is NDSII one image, S3 image and SWI image. So they have compared the ablation images and which of these indices is better, which of these indices is giving more separation. So here you can see a small dark patch. These patches can clearly be identified as snow, but what about water? So in SWI, can you see this? This 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 is clearly seen in SWI. This is water, and that's why in their conclusions they have said that SWI is better index even than NDSII and so on. So please go through this paper, read it, um, and you will know why these indices are very useful, why there is no stagnation as such. Na? NDSI develop hua, then NDSII develop hua, S3 develop hua, SWI. So people are always trying to see which are the better combinations of bands, which are the better maths that can be applied to these things, these bands, and how we can get maximum, how we can retrieve maximum information from the images. Then this is NDWI, that is normalized difference water index, another very useful and interesting index. Uh, See, this index is strongly related to plant water content and a good proxy for plant water stress. Plant में water कितना है? So Gao used NIR and SWIR bands for SWIR is SWIR, shortwave infrared, for deriving this NDWI. And here you can see that if MODIS data is used, MODIS band 2 should be used and MODIS band 6 should be used. If thematic mapper is used, then NIR and SWIR is used. So दोनों सेंसर का एक ही फॉर्मूला में देने की कोशिश की है. This also varies between -1 to +1 and depending on the leaf water content and also on the vegetation type and cover. This should always be remembered. Vegetation type और cover पे भी ये value depend करेगा. Now let us try to see this. Now when we say that water content in the plant, that means we need to know what is the structure of leaf. थोड़ा सा देख लेते हैं, ज़्यादा नहीं. So SWIR, which is used here, SWIR, it changes in both the vegetation water content and the spongy mesophyll structure. Now, what is this spongy mesophyll structure? This is the section of a leaf. This is the upper layer, and this is the spongy mesophyll layer, which is inside the leaf. Middle, you can say the layer of the leaf. So this ऊपर का layer, this layer is this palisade mesophyll layer, and this is spongy mesophyll layer. So mesophyll layer, as you can see, it is not compact. There are spaces in between. So these are air spaces. This creates air spaces because these are not compact elements. They have interstitial spaces, we can say. So bringing CO2 and releasing O2 and water vapor. So photosynthesis यहाँ भी चलता है, यहाँ भी चलता है. So there are not as many chloroplasts in the spongy mesophyll cells as they are in the palisade mesophyll cell, but photosynthesis still occurs in the spongy mesophyll layer. सबसे ज़्यादा photosynthesis यहाँ होता है. Most of the photosynthesis takes place over here because chloroplasts, chlorophyll का जो content होता है, chloroplasts, they are more over here. But here also they are not much in number, but still photosynthesis takes place. And NIR reflectance is affected by leaf internal structure, this internal structure, and dry leaf matter content, but not by the water content. वाटर कंटेंट कम ज्यादा हो, ये NIR से नहीं होता है, क्लोरोफिल से होता है. क्लोरोफिल कम ज्यादा होगा तो NIR का we have seen in NDVI that if there is more chlorophyll, then NIR gets reflected more, right? But if water content is different, then what happens? This NIR is not that sensitive. So water content, जो लिफ्ट में water content है, उसकी वजह से इसमें बहुत ज़्यादा कुछ change नहीं मिलता. So sphere band जो है, SWIR reflectance changes both, and the changes in both the vegetation water content and the spongy mesophyll structure. Spongy mesophyll structure में कितना water content है and total vegetation में कितना water content है, including stem and other parts of the vegetation. So the combination of NIR with SWIR removes variations induced by leaf internal structure and leaf dry matter content, improving the accuracy in retrieving the vegetation water content. So water कितना present है vegetation में, how much water is there can be known by applying this NDWI. So amount of water available in the internal leaf structure largely controls the spectral reflectance in the SWIR of the electromagnetic spectrum. So SWIR reflectance is therefore negatively related to leaf water content. This is very important, a leaf water content. If leaf water content is more, SWIR reflectance will be lower because it is negatively related. So it is useful for drought monitoring and early warning mm, has been demonstrated in different studies. You can just refer to these studies. Uh, References are given over here. So वाटर कंटेंट इन वेजिटेशन कम होता जा रहा है, इसका इंडिकेशन हमें दिस NDWI से मिल सकता है. So it is computed using NIR and sphere bands, SWR bands, which makes it sensitive to changes in liquid water content and spongy mesophyll of vegetation canopies. We have seen what this spongy mesophyll layer is and liquid water content within it. So this is one image of NDWI values, and it again ranges between -1 to +1. So these dark brown values माइनस की तरफ जा रहे हैं एंड पर्पल की तरफ ये जो दिख रहा है, so vegetation, increasing vegetation water content and fraction cover. So you can just see the values, yellowish values, they are around 0, and darker areas which are not much seen over here, यहाँ कुछ दिख रहा है, यहाँ कुछ दिख रहा है, they are, I mean, less or no vegetation covers, you can see. So what are the strengths and weaknesses of this particular index? So here, as we know that soil also adds its reflectances and adds its effect. If the land area is partially covered with vegetation, then of course soil background effects will be there, which cannot be nullified in this index. Moreover, soil cover is not masked out in the current version. There are other versions also, but in this version, um, snow cover is not soil, snow cover is not masked out. So during winter months, NDWI more than 0.5 may correspond to snow cover also. So it is another weakness of this index. So drought and water stress are not the only factors that can cause a decrease in NDWI. There could be other reasons also. No? There could be complete change of land cover or attack of pests and disease. They are also responsible for low reflectance values in SWIR. So therefore, this indicator must be used jointly with other indicators giving information on deficient rainfall or soil moisture. The soil data, rainfall data should also be there, and other indices like NDVI should also be coupled with this particular index. So actually there is one more version of NDWI. You can just, it is by McPhee. You can just search for it. NDWI का और एक वर्जन है, and then we have again NDMI. It is similar to, mostly the same with same as NDWI. This is moisture index, that is water index. So again the same bands are used over here, same formula basically. So sphere band is sensitive to vegetation water content and mesophyll structure. On the other hand, NIR is this is similar, but in literature you can find these two different indices, and I could see the similarities more. So I have included just to give you an idea that there is this type of, I mean, in literature you have both of these. So NDMI is used to monitor irrigation, especially in areas where crops require more water than nature can supply. Helps significantly improve crop growth. It is an excellent farm tool when the farmlands are very big. then you can apply this index. जहाँ physically जाके visit करके देखना कि what is the condition of the crop is very difficult, and then you can use such indices and know which corner of the farm is facing stress, water stress or other stresses. Typically all these things they are applicable or helpful in the areas where the farm sizes are huge. Um, in our case what we see is less than 1 hectare, 1 to 2 hectare plots are more, such farmers are more in our case, Indian cases. But in foreign countries, basically in North Europe as well as North America, whole of the US and Canada, the farm sizes are too big to visit physically, and such indices, such tools, they play an important role. So it can be used as farm tool, excellent farm tool. So dry conditions um, can be there in fire prone areas also. So uh, what happens, in for forest lands basically, some areas become very dry, and then uh, due to natural lightning also they catch fire. And if water is not available in those areas, it is the areas are facing much of uh, dry conditions, and if such areas are spotted early, then risk of fire can be minimized. So NDMI uh, can be used to know the fuel level monitoring also. Uh, so additionally, NDMI is better deforestation indicator than NDVI. NDVI से ये सारे बाद में compare होते रहे हैं. NDVI के कुछ limitations हमने देखा, and here NDWI, NDMI, they can be used for other purposes also. You know the range, it is again between -1 to +1 only. So +1 may indicate water logging, uh, and -1 water stress. So these are the two extreme conditions. Between these two conditions, we have many stages like NDMI interpretation. If you want to do, you can use this table, -1 to point. This also should be minus. I'm sorry. Uh, just a minute. -1 to -0.8 bare soil से लेके you can see almost absent canopy cover, very low canopy cover, dry or very low canopy cover, wet, then mid low canopy cover, average, mid high, medium to high, high canopy cover. As we go towards one, very high canopy cover, and the last is no water stress or water logging. So NDMI is another very important and useful index to monitor the water available in the whole ecosystems and other things. Um, Now, yes, these are some common things which we should not forget. NDMI values vary throughout the growing season because plants' reflectances do change with the stage of maturities. As the plant grows, in case of NDVI, you must be knowing that NDVI value goes down as the plant or the crop attains the maturity, and then उसके बाद क्लोरोफिल कंटेंट कम हो जाता है. We know that crop, when it begins to ripe, the chlorophyll content is less, and then dry leaf content becomes more prominent. And even if it is good in health, the NDVI values, similarly the NDMI values, they go down. So for each phenological stage, that is crop growth stage, these values will differ, and uh, there will be, uh, I mean, we should not compare the crop values for NDMI in the first stage and the last stage. Two first stage values can be compared, but not the first stage and last stage, because they will be different. So there also exists an interesting correlation between NDMI and NDVI. NDVI will always correlate with all these vegetation and moisture water indices. So water stress indicated by NDMI values can be confirmed by significantly lower than average NDVI values. So NDMI values का water stress कहाँ दिखेगा? Water stress will be somewhere here in negative values 0.2 and 0 के आसपास, and here also. And these areas will also give you lower NDVI values. So you can use these indices in combination for accurate readings, accurate measurements, and then only uh, conclude your studies. So applications can be summarized here. NDMI applications can be summarized. So for regularly monitoring the water content in plants, it can be used. Determine the farm zones with water stress. These are the patches of farm which are facing water stress. Improve the tree harvest logistics planning. कौन सा पैच का हार्वेस्ट करना है, that planning can be improved with application of this index. Then determine the combustibility levels of fire prone areas. Fire prone areas में जैसे मैंने बोला कि this basically applies to the forest fires. If the water content has gone down in whole of the region, then there is more probability of plant material to catch fire. Then there is one more, it is LWM. LWM is land and water mask. Land and water mask. Basically, what happens, when you are, I mean, we had used this while we were estimating suspended sediment in near shore areas, because we needed uh, reflectance values only from water area, and we needed to mask the land area. Land areas की reflectances हमें नहीं चाहिए थे, because our study area was near coastal area. So in such cases, what we need to do is we need to find out one threshold value, so below which, yeah, above which you are taking that class and below which you are not taking that class. So land and water separation becomes important when you are working, say, either on water bodies or either on land. You don't want to take water bodies within land and you are just working on the land portion of the surface of the earth. आपके एरियाज में बहुत बड़ा लेक है, but you are not considering that for the time being. Then what you need to do, you need to mask that water values, mask that area. So how will you identify the water bodies in the area? Then you will get the water values typically range between 0 to 50. So below 50 hai, to mask those areas. Don't consider the reflectance values from that areas. That means, okay, and these values range between 0 to 255. That means you take values of, say, green band or NIR band, and below 50 hai, so it is like uh, water. Above 50 hai, so it is land. So when you want to separate out land from water, water from land, whatever you say, this land water mask is used. So WM water mask is NIR divided by green plus 0.001 into 100, and ETM ka water mask, ETM plus ka water mask. ETM is a sensor, enhanced thematic mapper प्लस. पहले तो एनहांस थीमेटिक मैपर था, उसमें और थोड़ा इम्प्रूवमेंट हो गया, सो ETM प्लस. Water mask is equal to band 5. NIR is band 5 over there. Green is band 2 plus some constant 0.001 and 200. So in this way, you can separate out land and water, LWM, land and water mask use कर सकते हो. And I think these are some key references. Other references are given on the slides themselves. And yes, that's it. Thank you so much. Thank you, all the participants, all the organizers for giving me this opportunity. Uh, and yes, I will stop here. Thank you, sir. Thank you.
Thank you, ma'am, for a detailed journey of the indices. I'm sure all the participants may think upon to apply these indices and carry out their research work. Dear participants, if you have any question, any query, kindly feel free to talk with Dr. Gadkari ma'am. Please.
Yes, please let me know if you have any queries, any additions, any comments. You are welcome.
Ma'am, really you covered all the indices. It was totally impossible to cover within 1.5 hours, but you did it.
Not all, but I tried to
Yeah,
uh,
maximum possible
maximum possible,
indices.
because there are so many
Yeah,
versions
yeah,
of
yeah,
one
yeah.
index. It is not possible. And I think there are no questions, no comments. If you know something else, you want to add to something to what I have said, you are always welcome. There should be give and take, right? I will also learn from you. How to identify new indices? There is no such, a standard procedure to find out new indices. But let me tell you, when new satellites are planned, new sensors are planned, they are planned with some purpose. And if they are, suppose they are planned for coastal and ocean studies, then obviously which bands are useful for coastal and ocean studies, water bodies, those bands will be included in those indices. Then sample studies are done before launching the satellites. For so many years, our scientists work on these sensors, and then only those sensors are put in the satellites. So um, if one of my friends, she is working in space application center Ahmedabad. So that the ISRO was planning to launch a satellite with sensor specially dedicated to oceanographic studies, and especially for coral studies. So for years together, they were going to coral reefs in Lakshadweep, taking samples from there, reflectances from there, and then coming back, analyzing the things, which in which band they are reflecting, in which band they are not reflecting, and all those studies were first done in the lab, and then the indices or the bands are suggested for sensors, which bandwidth should be given for the sensor. And then as per the need, as in one of the slides, I must have told you that GAO especially um, designed this index in DWI for spot 4, spot satellite 4. So in this way, they keep on working, and then the indices are developed. If I have answered the question. Sir, I could not see any other question in the list also. There is one question. Is there also correlation between subsurface soil minerals and vegetation color? vegetation color or cover, I don't know, but yes, of course there will be uh, correlation between the soil minerals, maybe surface, and vegetation cover. Yes, there will be. Yes, sir. I will stop here today. I don't see any questions in the message box. Thank you so much, Patil sir. And
Thank you, ma'am,
congratulations for
for your.
conducting another very successful program this year also. Last year also
Definitely,
you had.
we will work for QGIS in Marathi language, and it is the need of new education, national education policy,
Yes,
and
definitely.
we will focus in vernacular medium, that is
Definitely.
Marathi, and I'm sure most of the UG students will be benefited through this activity.
Yeah, yeah.
Ma'am,
Yes.
thank you very much for your most educative, informative, and knowledgeful deliberations.
Thank,
Now, I invite one of my colleague, Pratiksha Mohite ma'am, to extend formal vote of thanks. Mohite ma'am, please.
Yes, sir. Good evening, everyone, to one and all presents here. I feel incredibly honored to have been allowed to extend a vote of thanks on the 13th day of the Digital Image Processing Workshop on the behalf of Department of Geography, ASP College, Devruk. I would like to special thanks to today's resource person, Dr. Gadkari ma'am, for accepting our invitation and take out time from your busy schedule to grace this workshop. Thank you, ma'am, for your valuable guidance. I also thanks to our Vice Principal and Head of the Department of Geography, Dr. Sardar Patil sir, to organizing such a great platform to our participants. And finally, I would like to thank to all the participants who have made this workshop possible. Once again, thank you all for your presence. Thank you all.
Thank you,
thank you
Mohite
everybody.
ma'am,
Thank you.
and Gadkari ma'am. Once again, I extend thank you very much on behalf of all the collaborating institutions and my team. Dear participants, tomorrow we will have Dr. B. Mahalingam, and I already talked about Dr. Mahalingam that he is the man of technology, and I am sure tomorrow you will enjoy the session delivered by him. So be in time. Thank you very much.